on the quiz?
Yeah, I thought it was today.
No, remember, I missed our last class, and when I came back at the end of the period, you guys said you had everything done, and I said, okay, well, then we can just have our quiz next time. And everybody said, no. So I caved and said, okay, well, we'll do it the next time. So we're gonna do it tomorrow, actually. But some of you are gonna do it after school. Some of you have already done it. So we'll get it done, but tomorrow is the official day. All right, so the paper I gave you is polar graph paper. When we graph in polar coordinates, and I'm not going to do the whole grid because it takes me too long, but I'll do this part of it. When we graph in polar coordinates, when I put a point on here, like that point right there, the coordinates of that point will be r and theta. R is which radius am I on? Well, if that's my point, I'm out 1, 2, 3. So my r would be 3. That first coordinate tells me how far out I am. Okay? And then the second coordinate tells me what angle I'm at. So that would be 45 degrees because the paper I gave you is in increments of 15. So the third one would be 45 degrees. So your points in polar coordinates, these are called polar coordinates, are r comma theta. So when you are given this, that means you're on the second circle out, and your angle is 2 pi over 3. Well, 2 pi over 3, let's do that in degrees. That would be, let's see, pi is 180 divided by 3 is times 2. So this is the same as 2 comma 120. Now, believe it or not, I'm so glad somebody asked this the question a minute ago about finding the components, because this question says convert to rectangular coordinates. Now, rectangular coordinates are the coordinates that you have used your whole life. They're called rectangular because what does your graph paper look like that you normally use? Isn't it like this, just a bunch of boxes? That's called rectangular. So if this is the origin, and I'm going to talk about that point right there, I count over 2 and up 1. That would be the point 2 comma 1. Those are what we call rectangular coordinates. And they are simply x comma y. So what is problem A asking me to find? They're asking me to find x and y. Well, wait a minute. Did I just do that in that airplane problem? Did I find x and y? How did I do that? X equaled something cosine angle. Guess what? X equals 2 cosine 120 and y equals 2 sine 120. That is all there is to it. If you are given your radius, which is 2, that's like the speed of the airplane, and you're given your angle, you just type in x equals 2 cosine 120, y equals 2 sine 120. And those are the rectangular coordinates. So 2 cosine 120 is -1, and 2 sine 120 is 1.73. There's the answer to the question. Finding rectangular coordinates means finding x and y, which is exactly what we did in the airplane problem. Components. To find x and y, we do 2 cosine 120, 2 sine 120. Every time. Okay? So let's look at the next problem, B. again, you've been given polar. And your job is to figure out X and Y. Anytime it says find rectangular, you're looking for X and Y. Okay? So what's X and Y going to be here? What's X? Negative 3 cosine 135. And Y is negative 3 sine 135. If you need something to write down to remind yourself, X equals R cosine theta and Y equals R sine theta. These are your general formulas that you're supposed to know already. You were given an R and given a theta. Those are your polar coordinates. So X equals negative 3 cosine, Y equals negative 3 sine. So your coordinates are 2.12 and negative 2.12. Everybody okay? All right, why don't you try C and D on your own? And I'll do them too, and we'll compare answers, okay? So try C and D. You're doing the same thing. You're trying to figure out what X and Y are. So you're going to do R cosine theta and R sine theta. Anybody have an answer to C? What'd you get for X and Y? Raven, you get it?
For C, I had negative 0.73, comma 0.68.
Shoot. I have the signs different than that. For C?
Yeah.
See, I had it flipped.
I have,
73 positive.
yeah, that's what I had. 0.73 positive. So did you do one?
Yeah, I think I did negative.
Oh, okay. Okay, yeah. So it's 0.73 and negative 0.68?
Yeah.
Kerwin, you okay with that?
Yeah.
All right. D. Quincy, what'd you get for D?
I'm not, I didn't finish D.
Because you don't have a calculator.
That's part of it, I guess, but.
Who has a calculator? I got Liam.
Negative 3.46 for X and 2 for Y.
Perfect. All right, so we're moving on. Let's stop and gather our thoughts. How do we find X and Y? X is always R cosine theta, and Y is always R sine theta. Right? Which ties in exactly with what's on our quest tomorrow. All right, now we're going the other direction. Okay, guys? Now it says I have an X and a Y, And I need to find the r and theta that goes with that. Now this is a little bit harder, not hard, but it takes a little more work. So I want you to draw a picture of 1, 2. So go over 1 and up 2 and make your little triangle. This right here is R. Think about if there were a circle there. Do you see how that would be the radius? That would be R. Now how could I find R? Looking at this triangle here, how could I find R real easily? Isn't that the magnitude of the vector? Yeah. So R is nothing more than the magnitude. You already know how to find magnitude. You do the Pythagorean theorem. So that's going to be root 5. This is called the direction angle. You know how to find that too. Or at least I hope you do, because it's on the quiz tomorrow. How do we find the direction angle? We need our calculator. We need to press a special button. What is it? Special tangent 2/1. And that gives us that angle, which is 63.43. Now, this is different vocabulary, but that is a test question tomorrow, guys. Only tomorrow it doesn't say find polar coordinates. It says find magnitude and direction angle. R and theta are exactly the same as what you do when you do magnitude and direction angle. The magnitude is root 5. The direction angle is 63. How about the next one, -3, 2? So think of that as x and y, because that's what it is, -3, 2. That's your x and your y. This is your r. What's my r going to equal? This is my r right here. What's that going to equal? Square root of 13? 9 plus 4? Now be careful, because your direction angle, theta, is this. First we'll find this one though. And how do we find that? What special buttons do we press to find that angle? Special tangent, 2/3, take or leave the negative, it's up to you. And then once we find that, second tangent, 2/3. I got 33.69. Once we find that angle, be careful, that is not theta. How do we get theta? 180 minus that? So what is that? 146.31. I'll check my arithmetic. Do you see the connection between what you're going to do on the test tomorrow and this? It's exactly the same. The only difference is on the test we call it magnitude and direction angle. Now we're calling it R and theta, polar coordinates, R and theta. All right, try the next two on your own. -3, -1, and 2, -4. See if you can get those. up here on the board. The answer should be written as an ordered pair. It's r comma theta, magnitude, direction, angle, but you're writing them as an ordered pair. So as you finish, look up here and see if we match. It's very possible I made a mistake. I did it very quickly. Very possible I made a mistake. So I'll need your help fixing anything that's wrong. Who's got a calculator today? Asia, we matching over there?
Because I missed the, because I didn't go the graduation of the
Okay, you mean the angle? Okay, so did you get this angle to be 18.43? Okay, now what you need to remember is your direction angle starts here always, okay? So think about going from here all the way over to here. How far did you go? 180, but you got to get down to here, so you're going to go past 180. So for that one, it's going to be 180 plus 18 because you're going past 180. Up here, Asia, we didn't make it to 180. So we had to do 180 minus because we didn't get to 180. It was less than 180. Now this one, your direction angle is all the way around here. If you went all the way up to here, that would be 360, right? But we didn't go to 360. We didn't make it that far. We only made it to here. So we'll find this angle by taking 360 minus 63, because we didn't make it that far. If you don't make it that far, subtract. If you make it past that, add. Does that help? Anybody else? Are we good? Okay, we're going to do a few more sections here. The next section says plot the points. Now, you can do it right on here. I also gave you some graph paper, but that's fine. You can do it right on here. That's why I put the grids on here. And they are labeled. So I'm going to set mine up just like yours. Oh, wait a minute. All right, and we're going to plot some points. All right, so here we go. We're going to plot some points. The first point we're going to plot is 2, 15. Now, what did I tell you about polar coordinates? What does the 2 tell me? Which radius to get on. So you're going to get on the second circle out, and you're going to get on the 15-degree line. So that first one is going to be right here. That's going to be point A. Point A is going to be right here. I'll label it A. That's point A. Does that make sense to you? Second circle out, angle 15. Now B, I tried to get tricky. What's pi over 2? 90. 180 divided by 2, 90. So we're on the 90 line, 3 circles out. So this is where I'm putting B. What do you think, kids? Are you all right with that? C, 5, 210. All right, here's the 210 line. And I need the 1, 2, 3, 4, the last circle. That would be point C, 5, 210. Oh, D, I got tricky again. What's 5 pi over 6? 150. So 4, 150, there's point D. Any issue with that? Because in the next set, they get a little harder. tell me if you're at all bothered by point E, which is -1, 30. Are you at all bothered by that? Is there anything about that that bugs you a little bit? What, Liam? Yeah, how do you have, this is R, right? This is the radius you get on. How do you have a negative radius?
What?
Time will pass, will you?
Yeah, well,
Now, you can't have a negative radius. So what we do is make it positive and change the angle to 210. Now, wait a minute, Mrs. Ford, what are you doing? Let me explain it. A negative radius means your point is actually plotted on the opposite side of the circle. When we talk about a circle, going from opposite side to opposite side is how many degrees?
180.
180. So instead, if you have a negative radius, it means your point is actually plotted on the opposite side. So instead of putting it at 30, it's actually going to be put at 210. So point E is on the first circle at 210. Anytime your radius is negative, you're going to make it positive. And to make it positive, you change your angle 180 degrees. Now that is not what's happening in point F. Point F is not an issue. What does an angle of -45 mean? I don't necessarily have it written up here, but it's up there. -45 means we go down. So we go down 45 degrees, so this line could be called -45. Because this one could be -15, -30, -45. So that point is on the second circle out. So this is point F right here. It's on the second circle out, down 45 degrees. A negative angle is perfectly okay. It just means you go down. Okay? G, what's that angle, 90? This is a problem. G is a problem. Because in G, the radius is negative. What did I tell you about that? You can't have it. You can't do it. So I gotta make that radius positive. But where will I plot my point then? Not at 90, 270. And why do I plot it at 270? Because when I have a negative radius, it moves my point halfway around the circle. And if I move halfway around the circle from 90, I would be at 270. So that point gets plotted on the 270 line, third circle out. So is that point G? And here's point H. I went ahead and made the pi 180. It's got a negative radius. Can't do it. Where are you going to plot it? You're not going to plot it at 180. Where are you going to plot it? At 0 or 360, right? However you want to think about it. So that point is going to be plotted right here. Point H is going to be plotted right there. Okay. Everybody's still with me? We're going to do one more thing, and that's it. One more equation. We're going to do problem 5A, just because it's fun. Who doesn't have a calculator today? Quincy's the only one, and Clayton. Clayton, can you share with Raven? And Quincy, turn around and share with these guys here, or come over and share with Gabby. We're going to do a graph now, a polar graph. These are fun. You're going to enjoy these a lot, but I need everybody to set your calculator up the way I am, okay? So let's go to our mode. Everybody press mode. Now we're going to go all the way down and highlight polar, P-O-L. So go down, in my calculator it's the fourth line down. I don't know what it is on yours. So we're going down, we're going to highlight polar. Because we're going to do a polar graph now. Okay? Is degrees highlighted already? I want everybody in degrees. Okay, now go to your window. Uh-oh. Remember how it used to say X min and X max? Well, now it says theta min and theta max. Do you know why? Because you're in polar coordinates now. Everything's in polar coordinates. So theta min, 0. Theta max, 360. We're going to go once around the circle. Theta step, let's use 3. X min, let me look at my equation. X min, let's use -4. X max, 4. Scale 1. Y min, -4. Y max, +4. Scale 1. Everybody have it set up like I said? All right, now go to y equals, where you normally put in an equation. Oh my, it doesn't say y equals now, it says r equals. And you're going to type in your equation, which is 2 cosine 3 theta. Now, theta, not 0, don't put 0, it's theta, and that's on your variable button, which is the button where you got X before. Now when you press it, it doesn't say X, it says theta, right? Hit graph, and watch this picture. Did you get a cool shape? You should have gotten what we call a 3-leaved rose. Did you get a 3-leaved rose? How come nobody acts excited? I mean, this is really awesome. Did you get a 3-leaved rose? You guys get one over here? What did you get? You got something different? You got it. Because you don't have your windows set up right. Really? Yeah, your Y max and Y min can't be the same number. All right. Now I'm going to show you another little trick that you might want to employ sometimes when you do this. Your screen is rectangular. It's not circular. Polar coordinates, remember with circular grid? So sometimes the picture comes out a little bit warped. Yes, because you have to put in theta. Now, so I want you to go to where it says zoom, up there in that top row of buttons, where it says zoom right next to your window button, and go down to 5, which is zoom square. What that will do is square up your screen so that you will see a perfect picture. It won't be warped. It still has 3 leaves, right? Can you tell how long those leaves are? Can you tell from the picture? You should be able to tell. How long are they? 2. The leaves are 2 units long. When I look at my equation, kids, r equals 2 cosine 3 theta. This number right here tells me the length of the leaves. So if I made that number a 3, I would get this exact same picture, except the leaves would be longer. So whatever number is out here in front is going to tell me how long they are. Now, what's your guess about this number then? How many there are? Now, wait, before we write that down, I want you to make one change to your equation. I want you to type 2 cosine 4 theta and graph that. So 2 cosine 4 theta, graph that one. Whoa, what happened? There's 8. Dang, shot that theory all to heck, didn't it? Anybody have a thought? Let's try another one. Same equation, but let's do 5 theta and see what happens. Ah, Gabby, say that a little bit louder. What have we observed?
If it's an odd number, it stays the same, but if it's an even number, then it doubles.
Exactly. So when you did this one,
Excuse this interruption. At this time this morning, in a few minutes, we'll be conducting our statewide tornado practice drill. So we're going to be testing
which is
several
awesome
other
for
things
us
with
because
that
we
drill.
just stay
One
right
is the
here.
PA system. So we need to know that if you cannot hear an announcement
We stay right here,
like this one, that you let me know.
and we'll bring kids
So
in.
you cannot hear the announcement. After we get you downstairs, we will, when we release, we will also release with a warning bell, and we'll practice that, make sure that works, and after that warning bell sets off, we will send you a text, as is our procedure to do that, let you know you've been all clear, so that will be your signal to come back when you receive the text that is all clear. So, at this time,